Okay, hi, I'm going to speak about EDCON. EDCON is what I call the Ethereum ontology. Closer to the mic. Okay, better now? Yeah. So I'm going to talk about EDCON, which is what I call the Ethereum ontology. I have to switch this on for it to work. And now it does. Okay, this is me. My name you already heard a couple of times now. I have an Ethereum account. I have a background in formal modeling, semantic web, data science, and similar things. I work for Consensys. I just thought I'd say that, so you know. And I also have a blog which you are welcome to look at. I actually love what William proposed earlier with his Ethereum taxonomy. I also work on the same question. What if Ethereum knew what Ethereum knows? So I'm just going to borrow this for now. But I will add another facet to it. What is EDCON? EDCON is an Ethereum ontology. It is derived from EDCON, which is one of the horses that pull the sun across the sky, and it's also, of course, an abbreviation for Ethereum ontology. Ontologies are formal and schematic descriptions of an area of knowledge. And EDCON is a multi-purpose Ethereum ontology. It takes all the blockchain terms we all work with, blocks, transaction, contracts, nonce, you can go on infinitely, not infinitely, and brings them into relation with each other and gives short and clear definitions. I'm not going to talk about the semantic web, which this plugs into. You will have to research that on your own. I'm not going to talk about reasoning, which is deriving new facts from existing knowledge. And I'm not going to talk about token launches, because I can't. I didn't pay for it. But I will tell you some facts about EDCON. EDCON is an ontology, I already said that. EDCON is a Ethereum reference. If you haven't used it for that purpose, you should. EDCON is also a data model. And I'll show you what you can do with this data model. And EDCON is a learning resource. If you talk to people that don't know much about Ethereum, you can use it to explain Ethereum to them. Or you can use it yourself to learn. And EDCON is extensible, and that makes it really powerful. How was EDCON created? There were many motivations, but one that is most important to me is the following. If the blockchain is our collective memory, and we've heard that notion a couple of times during this conference only, if the blockchain is our collective memory, and we leave artifacts in that memory when we are interacting with the blockchain, then we must be able to see what this memory contains about us, respectively about our avatars' identities that we use on the blockchain, but it's the same thing. Only then we can make informed decisions on what footprints we want to leave there on the blockchain. So, Ethereum is an ideal field for application of ontologies because a consensus about the semantics of the involved concepts is a prerequisite for reaching consensus about the state of the network. Any deviation from the consensus results in a fork. We have experienced that. An Ethereum ontology may serve as a semantic specification of its concepts that complements the technical specification. So it does not try to replace it, but it complements it. It's also a learning resource. So when you create an ontology, one approach is to go through all terms of a field of knowledge, to create a domain vocabulary from it. Then you arrange these terms in a class hierarchy, set relations and restrictions, and define their meaning properly. As an example, in the Ethereum block, in Ethereum, there's the concept of a block. We know that. All blocks must have a parent and a child block. The block here is the purple circle, and it has a relation to another block, which is called has parent block. It's that easy. So it must have a parent and a child block. This is true with the exception of the very first block, which only has a child, and the newest block for which the child has not yet been found. The newest block is always not there yet. Also, a block contains a list of transactions, which may be empty, and it's related here. So there's a relation called contains transaction. and block 7 associated miner who receives the block reward. And you can find it here in the relation has beneficiary. All these illustrations that I'm going to show you are created using a notation called vowel. You can see the key to the notation on the right. It's pretty simple. There are classes, there are instances, data types, and data instances, and a couple of relation types. And since EDCON is based on the semantic web technology, which I'm not going to talk about, all entities are identified by URIs. If you do it right, these URIs can be dereferenced, meaning they can be opened in a browser. If you go to HTTP EDCON Consensys net block, I get the EDCON definition of a block. So a block is the basic element of blockchain, blah, 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 blah. Blocks contain an identifier for the final state, and so on. But you also see that there's subclasses like a genesis block, and that properties of a block is that they have a parent block, a beneficiary, the block size, and so on. The standard EDCON ontology models lots of parts of the specification. For instance, EDCON models Ethereum completely as a state transition machine with a certain specialty of state transition machines, which means that they are typed transitions. So a transaction or a message call, they all create a different type of new state. And you can have sort state changes in these categories. Actually, there are many illustrations that show different parts of the model and how it represents concepts of Ethereum. Just go to the GitHub or to ethon.consensys.net and look at these illustrations. Maybe you can draw something from it. Okay, some of what you can do with EDCON. And this is only a tiny fraction of possible applications, of course. What can you do with this? Or you or others can better understand Ethereum. Less technical people will go, this is how Ethereum is organized. Or use it in your code or blog or anywhere you refer to Ethereum. Because whenever you're using EDCON terminology to refer to Ethereum, you can be sure people won't misinterpret what you're saying. This is because EDCON is self-explanatory. All terms can be looked up and properly relate to each other. Now let's see how we can formalize knowledge using EDCON. I'm doing this in a language called Turtle, but there are other languages that are maybe XML-based. Okay, first I say this abbreviation, EDCON, stands for my URL base, ethon.consensys.net. And then I say, okay, now I have this URL, etherscan io block 0, and I want to describe it. I'm saying this block has a type EDCON block, and it is a Genesis block. And it's also a block. Well, it's both. And it has the label Genesis block, because that's how I call it. You can also attach a comment. This is the Genesis block of the Ethereum blockchain. You can give it a number. So you formalize the knowledge that you have about this. And you can add other things. You can also add a see also relation, or you're free to do pretty much anything. So you can refer to the representation of the same thing on EtherCamp. You could also say this is your favorite block. You're not limited in what you do here, but you can model it to a strict data model and add and expand it as you need. Next, what you would like to do is probably exploit your knowledge. If you describe Ethereum in the way I just showed you, you will be able to design graph patterns for information that is interesting to you. In this case, this is a very simple example of a graph pattern that includes Vitalik. Vitalik is on the left side. This node represents an account that we know is his, because he gave away some information on DevCon 2. So the small circle to the right of Vitalik represents all messages that are directed towards his account. The next circle, the big blue one, represents somebody we choose to call a generous philanthrope. Just somebody who has fun sending money to Vitalik. The next small circle represents messages to his account of that philanthrope. And the last one is the origin of this message. We might call these guys these messages second-degree messages from Vitalik's viewpoint. The arrows attached to the messages represent the value in Vi here that is transferred with these messages. And when I say messages, that means transactions and what some call internal messages or internal transactions, any value transfer. The question we are modeling here is, where do the people giving Ether to Vitalik get their money from? Everybody should have, in my opinion, views on their identities on Ethereum that look like this. You should know what's happening. It helps creating a mental representation of your blockchain footprint. Now let's come to querying the data. If you model Ethereum in the described way, you can query it using, for example, Sparkle. Sparkle is a query language in a way similar to SQL, just it's for graphs. So we have this abbreviation again. We have another abbreviation we call Etherscan, so we don't have to write it out all the time. And we add address to the end. So anything after that is the address of an account. Now we want to select all generous philanthropes and all maybe dangerous philanthropes that fund people sending money to Vitalik. And then we sum up, but I'll show you that later. Okay, the query is, put all messages to Vitalik's account in the variable message. Then get all accounts that send these messages by the relation ethon_from, which is part of the ontology. And if you wanted to really know what ethon_to means, you can go to the page ethon.consensys.net/to, where it will be explained exactly what this relation actually represents. It represents any interaction, the to and from things, represent any interaction between accounts, whether it's by a contract message, called internal transaction also, or by a real signed transaction. And I also want the value of these transactions. And please save it in gift to Buttery. Then the next thing we do is we go to the second level, and we put all messages to these accounts in the variable message_to. And we do the same thing. We want to get the origins, and we want to get the values. And then we group by generous philanthrope and by dangerous philanthrope. And the result of this query will be a list of funds sent to Vitalik, including contract messages, and how the accounts sending that Ether were originally funded. The amounts each account has contributed are summed up for clarity. That's what we do here with the summing. That's just one example of many queries. And yes, I will not show you the result of this query. This is a small incentive to use Ethon yourself, or wait for our API release scheduled for, let's say, May. No features are promised. Now to some other stuff you can do with Ethon. Let's extend it. This model models all ERC20 token interactions and makes them queryable. So yeah, one query you might want to do is to see the total value transferred by a range of accounts for all ERC20 compliant tokens ever deployed to Ethereum. That's just one query. And referring to the previous talk, it's also always possible to know who spent the allowance. Here's a value proposition to you. Model your business use case using and extending Ethon. Use it as a data model for yourself and gain insights. For example, I created another not yet public Ethon extension for contracts. The data model allowed me to create all kinds of interesting queries. This was created in a single query. It shows opcode usage in contracts deployed recently, actually in blocks 3 to 3.1 million. The bars are the percentage of contracts that use a certain opcode at least once. Be careful, this is a logarithmic scale. So yeah, push and jump and some others, like those close to 100%, they are very popular. Xcode size, which was used as one of the opcodes used in the DOS attacks, is also quite popular, 12%. Difficulty is very rarely queried or used as a opcode. Yeah. You can expect some public releases of functionality based on this for the public chain and for the testnet soon. As I said, I won't promise any features, but it will be there. And whenever you act on a blockchain, this is maybe a takeaway. Whenever you act on a blockchain, remember what data scientists can do with the traces you leave there. Thank you very much. Are there any questions?
Yeah, so I understand you have this exhaustive database of every transaction and account, right?
You too, if you synchronize the blockchain.
Yeah, but I'm just curious how detailed it is. Does it also contain, for example, every operation in every, is it indexed also by like opcodes in every transaction, or is it?
I have the opcode thing is not in the standard Ethon definition that you would have if you just used Ethon, but I made an extension to that which was trivial that also includes all these things. Yeah.
How large is it?
200 gigabytes for the mainnet. It's okay.
So will this be also as a service query, or is something we use to build our own
Over time, we will offer different things, but at the beginning, you will not be able to run arbitrary queries because they are computationally expensive, but you will have a set of queries that are interesting, and you could, maybe you could, yeah, there are also offers that will allow you to run arbitrary queries, but you can also implement it on your own.
So, by definition, an ontology is a shared conceptualization that represents a community view. Have you put any thinking yet how you would make this, how you would get the community to validate?
Yeah. This ontology was derived using the specification, so it's a special case of an ontology. But it's not 100% representing what Gav wrote in the yellow paper, because community was involved. It's actually on GitHub and free for everyone to contribute. So that's the approach on including the community.